Welcome everyone in the video series of Fourier expansion. This is third video, and in this video I will talk about half range series. In case if you are new to the channel, do subscribe it and watch the video till the very end, then only you will be able to master the concept. What is the challenge here? First of all, I would suggest you that pause the video, note it down for your own reference, but I am going to explain. So the challenge is that there is a function that is f of x, and we are asked to write the Fourier series expansion of this function in the interval 0 to c. But here there is a specific task that has been given to us. The first task is that suppose I want to write the expansion of f of x in such a way that I get only the sine term or I get only the cosine term. So we know from our previous discussion that if the function is expanded in the interval minus c to c, and in minus c to c, if the function f of x is odd function, then what we get is the sine series. And if in minus c to c, if the function is even function is even, what we get is cosine series. But here they have just given half of the period, that is 0 to c. So to get a sine series, what we can do, we can extend the function in the interval minus c to 0, because when we extend it in the interval minus c to 0, our complete interval will be there minus c to c. And when we extend it in minus c to 0, what we do the extension, or we extend the function by reflecting the function in origin, or by extending the function in such a way that it is symmetrical about origin. It is symmetrical about origin, because we know the property of an odd function, that if a function is an odd function, it will be symmetrical about origin. Similarly, when we want to write the cosine series, in that case what we do, we also extend the function in the interval minus c to 0, but this time we extend the function by taking its reflection in y-axis, or we extend it in such a way that in the interval minus c to c, the function becomes an even function. So for that we have to extend the function in such a way that it becomes symmetrical about y-axis. Right. I hope you understand that why these things are being done. So just this thing I have summarized here, just so it will be able to help you, and you can create your own notes also. So you just look at this term, that how do we write the sine series? If it is required to expand f of x as a sine series in the interval 0 to c, then we extend the function reflecting it in the origin, so that f of x becomes minus of f of minus x. Then the extended function is odd in this interval minus c to c, and the expansion will give us the desired Fourier sine series. This is what I was explaining here, that if we extend the function in minus c to 0, what we will get is the desired Fourier sine series. And in this case, the expansion will look like f of x is equal to, n varies from 1 to infinity, bn sine n pi x by c. We know that from our earlier discussion, that in this case, if we are making the function odd in the interval minus c to c, the a naught term and the an term, both of the term will become 0. So I will get just bn term. And how the bn will be evaluated in this case? The bn will be evaluated by using the formula, that is 2 by c 0 to c f of x sine n pi x by c dx. Same thing is with cosine function. If it is required to express f of x as a cosine series in the interval 0 to c, we extend the function by taking its reflection in y-axis, and by doing so what we get is an even function in the interval minus c to c. So if we get an even function in the interval minus c to c, the coefficient bn will become 0, and the Fourier series will look like f of x is equal to a naught by 2 and summation n varies from 1 to infinity a n cos n pi x by c, where a n is calculated using this formula and a n is calculated using this formula. So to make sense of it, I am going to take some examples. But before I take the example, I want you to be clear about this important remark, that it must be clearly understood that when we expand the function in 0 to c as a series of sine or cosine by just considering it as an odd or even function of period 2 pi, it does not matter whether the function is odd or even or neither. So what is the basically point here? That when I am looking at the function as such, the function f of x as such may be odd function, maybe even function, maybe any kind of function, or it may neither be odd nor be even. But what we are doing, if it is given in the interval 0 to c, we can extend it in such a way in the interval minus c to c, so that in this interval it becomes either odd or even, right? So let us understand it through these examples. I am going to take three very interesting examples, so watch the till the very end, because the last example will be more interesting and lot of questions are asked from that example also. But to start with, let us take some simple example. So suppose I have a function f of x is equal to x and I want to expand it as a half range sine series. So first of all, if you look at this graph of this function, see, drawing the graph is not important because I'm just explaining it for the first time. I am drawing the graph. You can directly write your answer as such. So if you look at this function, the function is defined in 0 to 2, and the graph of the function is f of x is equal to x will look like this. Now this is not the complete range, because we want the complete range from -2 to 2. So what we have to do, we have to expand the function. So how do we expand the function? Because I want to make it an odd function, because I want the sine series, so I have to make it as an odd function. So I am going to extend the function by taking its reflection along or in origin, means we draw the graph in such a way that it is symmetrical about origin. So now this function here in -2 to 2 is an odd function, because you can see that it is symmetrical about origin, right? So once we have done that, what we will do, we will write the Fourier sine series as f of x is equal to summation n varies from 1 to infinity bn sine n pi x by 2. I hope you remember the result, that this is how the Fourier sine series is written, bn sine n pi x by c, and here because we are taking the interval -2 to 2 after expanding the function, the c value is equal to 2, right? Now how to calculate the Fourier coefficient bn? So the Fourier coefficient bn formula is given by 2 by c, so here it will be 2 by 2, limit of integration is 0 to c, that is 0 to 2, and f of x is equal to x, and then we write sine n pi x by 2 dx, right? This is the formula, I hope you remember, 2 by c, 0 to c, f of x sine n pi x by c dx. Now we just have to integrate this, so those 2 and 2 cancel, and here we can apply the integration by parts. So x being the first function, and we will integrate sine, let me write it. So I will integrate sine n pi x by 2 dx minus integration of sine n pi x by 2 dx into differentiation of x, and then we integrate the whole thing. Limit of integration is 0 to 2. Integration by part is very important, so in most of the problems we are using this. So I hope you will be able to write this step directly. This was not needed at this level, but for your understanding I have written. So x integration of sine will give me minus cos n pi x by 2, and I need to divide it by the coefficient, that is n pi by 2, so means I need to multiply it by 2 by n pi, and if I integrate this thing again, I will get minus cos n pi x by 2 and 2 by n pi. So this will be like, it will become plus 2 by n pi is a constant, so I will write it outside, and what I will get is cos n pi x by 2 dx. So, and dx by dx is equal to 1. So should I write it directly? If I integrate cos n pi x, I will get sin n pi x by 2, and again the coefficient will be n pi by 2, which will be divided, means here it will be multiplied, so it will become a square, and here the limit of integration is 0 to 2. Lot of students make mistake in putting the limit, so look at this very carefully. If I have to put the limit, what I will get, first I put the upper limit, that is 2. So here we will write x is equal to 2, here we have 2, here we have minus, so I will get minus 4 by n pi, and I will get cos n pi into 2 by 2, so 2 cancel, so I will get cos n pi. If I put 0 here, 0 into this will make it 0 in the first term. Now if you look at the second term, if you put 2 in place of x, you will get sin n pi 2 by 2, so 2 cancel, so you will get sin n pi is equal to 0, and if you put 0 again, sin 0 is 0, so everything will become 0 except this term. So this is nothing but 4 by minus 4 by n pi, and cos n pi is minus 1 to the power n. So moving ahead, if I have to expand this, what will be the sine series expansion? It will be summation n varies from 1 to infinity, and bn I have got minus 4 by n pi into minus 1 to the power n, and here I will have the term that is sine n pi x by 2. So just for you can leave it as such, but for just our understanding, I am going to write the details again. So if I take n is equal to 1, and here you can see that 4 by pi is a constant, so that I can take out of the summation, and if I take n is equal to 1, minus, and minus 1 to the power 1 will make it plus, and here n is equal to 1 will give me sine pi x by 2. If I take n is equal to 2, then it will become plus, it will become minus, so I will get minus 1 by 2 and sine 2 pi x by 2, so 2 pi x by 2. If I take n is equal to 3, it will be like positive again, so I will get plus 1 by 3 sine 3 pi x by 2, and so on. So this is the Fourier expansion, and here we are just getting the sine terms. So this is the Fourier sine series expansion for this function. Let us quickly write the Fourier cosine series expansion for the same function. So if I look at this function f of x, we have the same function, and now I want to write half range cosine series in the interval 0 to 2. So to write the half range cosine series, what you have to do, you have to extend the function in the interval minus 2 to 2, means you have to you can write it like if you want to draw the graph, fine, or you can even simply write that we extend, let me write this time, we extend the function f of x is equal to x in minus 2 to 0. It is given in 0 to 2, so I will expand it in minus 2 to 0, so that the new function is symmetrical about what? About y-axis, because I want to make it an even function. If I want to write it as an odd function, I will make the new function symmetrical about origin, but since I want to make it an even function, I will extend it in such a way that it is symmetrical about y-axis. Hence the Fourier series f of x over the period in this case will contain the cosine term only. So the Fourier series will look like what? The Fourier series f of x in this case will contain a0 by 2 plus summation n varies from 1 to infinity an cos n pi x by 2, and we have to calculate an. So to calculate an, the formula is 2 by c, so here it is 2 by 2. I hope you are lot of students make mistake in identifying C. In the this interval is given to be 0 to 2, which I have extended from -2 to 2, and I am comparing this with interval minus C to C. So the C value is 2. So 2 by 2, limit of integration is 0 to 2, and f of x is x, and then we write dx. So this 2 and this 2 cancel. What I get is x square by 2, limit of integration is 0 to 2. So 2 square by 2 will be equal to 2. So the first term I have got is 2. Now I am going to calculate an. So to calculate an, again 2 by c, so that is 2 by 2, limit of integration is 0 to 2 x, and what I will get this remember this result here. Just for your reference I am showing you so that you do not miss. So how do you calculate this? An is equal to cos n pi x by c, and when I was calculating bn, I was writing sin n pi x by c. But I also want you to realize that if you are writing the coefficient of cos term, you need to multiply it by cos term, right? So this is what I wanted you to understand, so that you don't get confused, because I want to get an, and here an is what? An is the coefficient of cos term, so I need to multiply it by the cos term. So I will write cos n pi x by 2 dx, and this time I have to use integration by parts, and I will not be writing the detail because now you are mature. Mature. So an is equal to x, the first function, integration of cos n pi x by 2, so that is sin n pi x by 2, and what is the coefficient? N pi by 2. So when we integrate, we divide, so we multiply it by 2 by n pi, right? And then we have minus integration, so 2 by n pi is already there, and we will integrate sin n pi x by 2, because dx by dx will become 1. So sin n pi x by 2 will give me minus cos n pi x by 2, means it will become plus, and this term will become a square, and here I will get cos n pi x by 2. I hope you got this point. I repeat it. First function, integration of cos n pi x by 2 will give me sin n pi x by 2, and I need to multiply it by the coefficient 2 by n pi, because if I divide it, it is n pi by 2, and here it is minus, but because you know, in the next step, when I will be integrating sin n pi x by 2, this minus will become plus, and this is what we will get. Please complete it like the way I have done in the previous problem. Here the Fourier series, so I have written the detail, but I wanted you to be able to write it directly also, so I have written it directly. Now the limit of integration is 0 to 2, and I am explaining it here itself that in this term, let me change the color. So in this term, if I put 2 here, I will get sin n pi 2 by 2. So I will get sin n pi. So it will become 0. And if I put 0 here, sin 0 is also equal to 0. So both this upper limit and lower limit value will give 0 here. So if you focus on this, you will get, if you put 2 here, you will get cos n pi, and here you will get cos 0. So let me write in the next page. So what is the an that we are getting? An that we are getting is, here we have this term become 0, and here we are getting 2 by n pi square, so that I write 4 by n square pi square, and if I put the upper limit, I will get cos n pi, and lower limit will give me cos 0. So I will get cos n pi minus cos 0. So this is basically equal to 4 by n square pi square. Cos n pi is minus 1 to the power n, and cos 0 is equal to 1. So this is an. So if I ask you what is a1, in exams they ask this kind of question. So it will be minus 1 and minus 1. So I will get minus 8 by 1 square into pi square. A2 will become 0, because minus 1 to the power 2 will become 1, 1 minus 1, 0. What will be a3? So a3 will be, here again it will become minus 8 by 3 square pi square. What will be a4? A4 will be equal to 0. What will be a5? A5 will be equal to minus 8 by 5 square pi square. I hope you got it. So what is the cosine expansion? So x is equal to a naught by 2. What is the a naught? I have got 2. So I will get 2 by 2. So that is equal to 1. And minus, from all these terms, 8 by pi square can be taken common. Or let me write it, otherwise you will get confused. So I am writing a1 cos x. So I will write minus 8 by 1 square pi square cos x. Then a2, so 0. Then a3. So a3 is minus 8 by 3 square pi square cos 3x. Then a4 is 0, a5, so that is minus 8 by 5 square pi square cos 5x, and so on. So what did I get? I get x is equal to 1 minus 8 by pi square can be taken common. I will get cos x minus 1 by 3 square cos 3x, not minus, rather plus, right, and plus 1 by 5 square cos 5x, and so on. So okay, there is, I think, a small mistake here. The mistake is that our expansion is an cos n pi x by 2, and I am just writing cos x. So just correct it. Here it is not cos x, it will be cos, for 1 it will be, let me write here so that you don't miss, n pi x by 2. So if I take n is equal to 1, I will get cos pi x by 2. So just a small correction. You remove this. So what I will get? I will get cos pi x by 2. Here I will get, for 3 I will get cos 3 pi x by 2, and for 5 I will get cos 5 pi x by 2. So here also let us make this correction. I realized it very quickly, otherwise I could have missed this point. But I would suggest a student to be clear about this thing. So I am writing cos pi x by 2, cos 3 pi x by 2, and here it is cos 5 pi x by 2. So this is the cosine series expansion in case of the Fourier series. X can be written as 1 minus 8 by pi square cos pi x by 2 plus 1 by 3 square cos 3 pi x by 2, and so on. So we have done two simple problem. In one, what I did, we extended it by taking its reflection along the origin. In the other problem, I extended the function by making it symmetrical about y-axis. Now let us do this problem, and this will be a slightly lengthier problem, so you need to be very careful, otherwise you will miss the main point that I want to highlight, and that will be like in the last part of the problem. So just look at this. So here again, ladies and gentlemen, if I have to write the Fourier series expansion, but they are asking me to write the cosine series. Okay, so how will I get the cosine series? So let me write the solution and then I will talk. Writing is more important than talking. So solution. I think red ink looks better. So basically I want to write it as a cosine series. So when do you get the cosine series? When you extend the function in such a way that it is even function in the interval, that is minus pi to pi. Here the half interval is given, that is 0 to pi. We have to make it a full interval, that is minus pi to pi. And how? By expanding the function by taking its reflection along y-axis. So what I am doing, I am just writing it. So we will extend the function x sine x in minus pi to 0, so that the new function is symmetrical about y-axis, right, and represents an even function in minus pi to pi, right? So once we have written this, like some of you might be thinking, do I need to draw the graph? No need to draw the graph. That much of information is sufficient, that originally the function is defined in 0 to pi. You have extended it in minus pi to pi, and for extension what you have done, you have drawn the graph symmetrical about y-axis. So in the interval minus pi to pi, now it becomes an even function. You wanted even function because you want to write the cosine series expansion. So in this case, what will be the expansion? X sine x will be equal to a naught by 2 plus summation n varies from 1 to infinity a n cos, now n here c is equal to pi, right? So it will be just cos nx. Okay, and how the a naught will be calculated? A naught will be calculated as 2 by c, that is 2 by pi, and a limit of integration is 0 to pi. The function here is x sine x dx. So this is integration by parts problem. I write it directly. 2 by pi x first function, integration of sine is minus cos. So this minus will become plus, and then sine will again give me cos. So cos x, limit of integration is 0 to pi. So if you put the limits, what will you get? You will get 2 by pi, and just by putting the upper limit I will get minus pi cos pi, and by putting 0 it will become 0, right? And here I think we made a mistake, because first function integration of second function, that is sine x, that will give me cos x, and when I will integrate cos x I will get sine x. So a smart student might already have realized, but when I was substituting the limit I was sure that I have made a mistake. Now sine 0 will become 0, and sine pi is also 0. So if I put pi or 0, this term will become 0. So that will be what we will get, and this pi and this pi will get cancelled, and cos pi is actually minus 1. So this minus and minus will become plus. So what I get is 2. So the first coefficient a naught that I have got is equal to 2. Okay. Now let us talk about the next Fourier coefficient, that is an, and it is slightly tricky, so be very careful. So an is equal to 2 by pi, 2 by c, limit of integration 0 to pi. The function is x sine x into cos nx dx. And those who have watched the first video, they possibly might be aware that what we need to do with this kind of function. So I'm writing it like this. I'm writing 2 by pi. Here I am multiplying it by 1 by 2, and here I am multiplying it by 2. So they will cancel each other. So I will get x, and here I will write 2 sine x into cos nx dx. This is a standard practice. I have made the function 2 sine a cos b, and we remember the formula. So this 2 and this 2 is cancelled. What I will get here is 1 by pi. Limit of integration is 0 to pi x, and 2 sine a cos b is sine a plus b. So sine x plus nx, sine x plus nx, and plus sine a minus b. So that is sine x minus nx, right? And then we have to integrate. So for our simplicity, I can write 1 by pi, and here I write 0 to pi x. This x plus nx can be written as sine n plus 1 x, and here x minus nx, I hope you remember the result, that sine minus x is equal to minus sine x. We have used it multiple times. So it will become minus 0 to pi x sine n minus 1 x dx. I hope you agree. This can be minus can be taken outside, so the sine minus x will become minus of sine x, and I have to apply integration by parts on both these terms, right? So I'll be doing it separately. So let me write here. So this will be like 1 by pi, and again I'll be writing directly. You are mature now. So first let me talk about this integration. Sorry. So first function x, integration of sine is minus cos n plus 1 x divided by n plus 1, and this minus and minus will become plus, right? So I will write plus, dx by dx will become 1, and cos n plus 1x will give you sin n plus 1x. So I will get sin n plus 1x divided by n plus 1 square, and this close the bracket, limit is 0 to pi, and I'm writing it with the different ink so that you understand it carefully, minus. For this part again I write x as the first function. Integration of sin n minus 1x is minus cos n minus 1x divided by n minus 1, and minus and minus will become plus. So again we have to integrate cos n minus 1x, so that will give me sin n minus 1x by n minus 1 square, and here the limit of integration is again 0 to pi, and I need to close this bracket, right? So now let us do the substitution of the values. So I am writing it 1 by pi, right? And if I put the upper limit, I will get minus pi cos n plus 1 pi divided by n plus 1. And if I put the upper limit here in this, sin n plus 1 pi will become 0. If I put 0 here, x in 0 into anything will become 0. And if I put 0 here, sin 0 will be equal to 0. So every term other than the first will become 0. And this is the first part. This is the first part. And if I talk about the second part here, I will get what? I have to put pi here, so it is minus. So it will be like minus pi cos n minus 1 x by n minus 1. And if I put 0, lower limit, 0 into this will become 0. In sin n minus 1 pi is 0, sin 0 is 0. So I just get this term, right? So now I can, for our convenience, you can clearly see that pi can be taken common, and this minus and this minus will become plus, right? So I am writing it, this plus term and this term will become minus term. So I am writing this term like cos n minus 1 x by n minus 1 minus cos n plus 1, not x, sorry, pi. So cos n plus 1 pi by n plus 1. But the point that I wanted you to understand, this is the value of an that I have got. And here is the trick. What is the trick? That this value of an that I have got, when we take the summation here, you can see that summation is from n to n is equal to 1 to infinity, right? But if you look at this expression, if you take n is equal to 1, this will become 0 in the denominator. So this will not be defined, right? So this an value will be considered only suitable when n is not equal to 1. So the question is that what if n is equal to 1? So for that, what we have to do, we have to do the calculation separately. So when we take n is equal to 1, we have to calculate a1 separately. And what will be the formula of a1? It will be like 2 by c, so that is 2 by pi, limit is 0 to pi. The function, that is what is the function? X sin x. So I will write x sin x, and then in general result we write what? In general result we write cos nx. If we are calculating an, we are writing cos nx. But if we calculate a1, I will just write cos 1x means cos x. So I will write here cos x dx. Again, this thing can be written as 1 by 2 into 2 by pi, and here we will have 0 to pi, and if I multiply by 2 here, we will have 2 sin x into cos x, so that will give me x sin 2x dx. This can be asked as a multiple choice question, that what is the Fourier coefficient for n is equal to 1, and in the MCQ they ask questions like this, that they specify that find a1 or a2 or a3. So in spite of writing the whole thing in terms of n, you can directly calculate that. Now this 2 and this 2 is cancelled, and I have 1 by pi here. On this I have to apply the integration by parts. So x is the first function. Integration of sin 2x is minus cos 2x by 2 minus integration of this, so it will make it plus, and I will get cos 2x by 2, whose integration will become sine 2x by 4. Limit of integration here is 0 to pi. So if I put the limits here, I will get what? I will get 1 by pi. So and minus cos 2 pi. So cos 2 pi is equal to 1. Cos 2 pi is equal to 1. So I will get here minus 1 and by 2, and here I will put pi. So I will get what? I will get, let me write it, otherwise you will see that. So I write minus pi cos 2 pi by 2. If I put pi, if I put 0, 0 into this thing will become 0. If I put pi here, sine 2 pi 0. If I put 0 here, sine 0 is equal to 0. So this pi and this pi is cancelled. So what is a1? a1 is minus 1 by 2, because cos 2 pi is equal to 1. Okay, now comes the other part, that we have to write the expansion, and we also have to prove this result. So here also a lot of people will make mistakes. So if I have to write the expansion, I have got a naught. Let me write for our convenience the information that we already have. A naught I have got is equal to 2. So let me write here so that we don't have to turn again and again. So a naught is equal to 2 I already have got. And what I have got as an I have got as cos n minus 1 pi by n minus 1. So I have got cos n minus 1 pi divided by n minus 1 minus cos n plus 1 into pi divided by n plus 1. So a naught, a1, what will be a2 if I calculate it? Because if I write the expression, it will become very complicated. So let me calculate a2 here separately. So if I calculate a2, I will get cos 2 minus 1 pi. So I will get cos pi, right, divided by 2 minus 1 is 1, and minus cos 1 plus 1, that is I am taking 2, because 1 I already have calculated, so I am taking 2. So 2 plus 1 is 3 pi by 3. Now how much is this? Cos pi is minus 1 by 1, and cos 3 pi is also minus 1. I hope you understand this, that cos n pi is minus 1 to the power n. So this will be minus 1 if n is odd, and this will be 1 if n is even. So that is what we are using. So it will be minus 1, so it will become plus 1 by 3, which I can write minus 3 plus 1 by 1 into 3. So I will get minus 2 by 1 into 3. You might be thinking why you are writing like this, because if you look at this expression, the expression is appearing in this form. So I am not writing 1 into 3, I mean directly 3, I am writing it 1 into 3. If I calculate what is your a3, so you have to put 3 here, so it will become cos 2 pi by 2, and if you put 3 here, it will become cos 4 pi by 2, and both of them are positive, like 1. So I will get 1 by 2, and I think if I put 3 here, it will be 4 here. So 1 by 2 minus 1 by 4, so that will be 4 sorry, if I take 2 minus 1, 2 minus 1 by 2 into 4. Okay, so I will get what I am doing. It is if LCM is 2 into 4, so 4, so here 2 minus 1, so I will get 1 by 2 into 4. Okay, is it okay or not? So again, I think I need to make a small correction, because I want to write it in that form. It is like LCM is not 2 into 4, LCM actually is 4, but so that is why. So I am writing it in this form, 2 into 4, so it will be 4 minus 2, so that will be 2 into 2 by 2 into 4. Now what will be a4? So a4 will be, if I take 4, I will get cos 3 pi by 4 minus 1 is 3, and minus cos 5 pi by 5. So again cos 3 pi is minus 1 by 3, and this will be like plus 1 by 5, because both of them are negative. So it will be like minus 5 plus 3 by 3 into 5. So I will get minus 2 by 3 into 5. Now possibly you might have got the drift here, that what will be a4. So if I write a4, it will be like sorry, not a4, a5. So what will be a5? If it is a2, I am getting negative. If it is a3, I am getting positive. Then I am getting negative. a5, I will get positive. So I will get 2 by and if it is a4, I am getting 3 into 5. So if it is 5, I will get 4 into 6. If I ask you what is a6, so you can guess that it will be minus 2 and it will be 5 into 7. If I ask you what is a7, so you will get it is 2 by 6 into 8. So this is how we are getting the coefficient, but we have to write the expansion. So let us write the expansion in the next page. So the expansion is we x sine x is equal to a naught by 2 plus summation n varies from 1 to infinity a n cos nx. Right. Now this is actually equal to a naught by 2 plus a1 cos x plus a2 cos 2x plus a3 cos 3x plus a4 cos 4x and so on. So what is this x sine x? So x sine x, what is a naught I have got? A naught I have got is 2, so I will get 2 by 2, so that will give me 1. And what is the a1 I have got separately? That I have got minus 1 by 2, so I will get minus 1 by 2 cos x. What is the a2 I am getting? A2 I am getting minus 2 by 1 into 3, so minus 2 by 1 into 3 cos 2x. What is the a3 I am getting? A3 I am getting 2 by 2 into 4, so I write 2 by 2 into 4 cos 3x. What is the a4 I am getting? So I am getting minus 2 by 3 into 5 cos 4x. I am writing more terms so that you are clear. Now what is the next term? Next term will be 2 by 4 into 6 cos 5x. The next term will be minus 2 by 5 into 7 cos 6x and so on. So these are the terms that I am getting. Now this is the Fourier series expansion, but that is not the end of their story, because they also want us to prove this result. So you can clearly see that I want this term 1 into 3 term, I want 3 into 5 term, I want 5 into 7 term. So I don't want this 2 into 4 terms, this 4 into 6 term. So what possibly can be done? It is cos 3x, it is cos 5x, and we know that cos for odd multiples of pi by 2, 2n plus 1 into pi by 2 is equal to 0. So since we know this result, it makes sense that if I take x is equal to pi by 2, what will I get here? I will get x sine pi by 2. So I will get pi by 2 into sine pi by 2, that is 1. So I will just get pi by 2. And I will get 1 minus cos pi by 2 is equal to 0. So this term will become 0. Cos 3 pi by 2 will become 0. Cos 5 pi by 2 will become 0. So I will get 1 minus 2 by 1 into 3, and here I will get cos pi. Then I will get minus 2 by 3 into 5. Here I will get cos 2 pi. Then here I will get minus 2 by 5 into 7. I will guess cos 3 pi and so on. This is what we are going to get. Now this can also be written as pi by 2. This 1 can be brought in the left hand side, and here cos pi is equal to minus 1, cos 2 pi is equal to plus 1, cos 3 pi is equal to minus 1. So I will be getting what? I will be getting 2 common, and this will become positive, so I will get 1 by 1 into 3. This is negative, so I will get minus 1 by 3 into 5. This will become positive, so I will get plus 1 by 5 into 7. And now I hope you have got the drift. So finally we have got the answer. So 1 by 1 into 3 minus 1 by 3 into 5 plus 1 by 5 into 7 and so on is equal to, this is pi minus 2 by 2 and I will divide it by 2. So this will become pi minus 2 by 4, and that completes the answer. So it has taken me a lot of time because I have to calculate a naught, I have to calculate a1 separately, I know, and then even after I have got the Fourier coefficient to evaluate the different Fourier coefficient also was something that I have to do separately, otherwise it will be like confusion. So it is better to avoid confusion and spend some time. Now with this I complete this video. I discussed 3 interesting problems related to sine and cosine series. So in this Fourier series expansion I talked about how to write the, and I'm giving you the overview of all the 3 videos along with this. That in the first video I talked about Fourier series, how to write the Fourier series, right, how to write certain integrals, certain interesting characteristic. In the second video I talked about Dirichlet's condition, writing the Fourier series for the case when the function is odd or even in the interval minus c to c, and I also talked about writing the Fourier series for those functions which have a certain discontinuity and the function is not continuous at certain point. In this video I talked about how to write the sine series or cosine series. So the function may be given, f of x may be given in the half interval, that is 0 to c, and I want to write the sine series, so I have to extend it from minus c to c. So I have to complete the entire interval, that is minus c to c, and I have to extend the function in minus c to c in such a way that what I get is an odd function, because if I want to write the sine series I want to see the function as an odd function. If I want to write the cosine series I want to see the function as an even function. So how can you see the function as an even function? If you extend the function in minus c to c and you extend it in such a way that it is symmetrical about y-axis so that it becomes an even function. So this is what all I have discussed. So in case if you have watched the video till the very end, please do share with all your friends and like the video as well. Thanks for watching.